my name is Daniel, and today we will be going through the 2003 AMC 10B. So let's get started. First problem, which of the following is the same as 2 minus 4 plus 6 minus 8 plus 10 minus 12 plus 14 over 3 minus 6 plus 9 minus 12 plus 15 minus 18 plus 21. So if you see, then this is 2 over 3, 2 over 3, 2 over 3. So the ratio is all 2 over 3, so we can just say that this is 2 over 3. The answer is C. Number 2, Al gets the disease algebraitis and must take 1 green pill and 1 pink pill each day for 2 weeks. A green pill costs $1 more than a pink pill, and for 2 weeks his pills cost a total of $546. So let's get the amount for 1 day. 546 divided by 14, right? This is 39. So 39 equals a green pill, a pink pill, plus 1 plus pink pill, since this is a green pill. So pink pill equals $19, and so green pill will equal $20. The answer is D. Number 3, the sum of 5 consecutive even integers is 4 less than the sum of the first 8 consecutive odd counting numbers. Okay, so a minus 2, a minus 1, a minus a, yeah. A plus 1, a plus 2. So the sum of these is 5a is 4 less than the sum of the first 8 consecutive odd counting numbers. So 1 plus 3 plus 5, 7, 9, 11, 13, 15. Right, so this minus 4. And the sum of the first 8 counting numbers, this is 64. Since it's 8 squared, this minus 4 equals 60. A equals 12, the smallest of the even integers. Oh yeah, so it's even integers, so it's a minus 4, a minus 2, a plus 2, and a plus 4. So the smallest of the even integers is a minus 4, so a minus 4 equals 12 minus 4 is 8. The answer is B. Problem number 4. Rose fills each of the rectangular regions of a rectangular flower bed with a different type of flower. The length in feet are shown as below. She plants 1 flower per square foot. Asters cost $1 each. Begonias $1.50. Cannas $2. Dahlias $2.50, and Eastern lilies $3 each. What is the least possible cost in dollars for her garden? Okay, so let's figure out how much this is. This is a 2, and this is a 2. Okay, so the area would be 20. This will be 21. This will be 15. This will be 4. This will be 6, and we don't need these 2 measurements. Okay, so the least possible cost, which means that the flowers costing the least would have to take out the most space. So it's 1 times 21 plus 1.5 times 20 plus 15, yeah, plus cannas, so it's 2 times 15 plus 250, 2.5 times 6 plus 3 times 4. This is 21, this is 30, this is 30, this is 15, and this is 12 if you add them all together. This is 81, this is 27, this is 108, so the answer is A. Problem number 5. Mo uses a mower to cut his rectangular 90-foot by 150-foot lawn. The swath he cuts is 28 inches wide, but he overlaps each cut by 4 inches to make sure that no grass is missed. So basically what he cuts is 24 inches, right? Because he overlaps by 4 inches. So 24 inches, this is 2 feet. And then he walks at the rate of 5,000 feet per hour while pushing the mower. Which of the following is closest to the number of hours it will take Mo to mow the lawn? Okay, so he walks at the rate of 5,000 feet per hour. So 90 foot by 150 foot. 90, 150. And so he would be mowing 2 feet each time. And then so he would take 45 trips. 45 trips of 150 feet. And so 5,000 feet per hour, right? So 45 times 150, this is 24. 45, 245, 675, 6,750. So this 6,750 feet, and so per hour, right? 6,750 over 5,000. This is the number of hours. This is 1,000, and then 1,350. This is 1.35. The answer is C. Problem number 6. Many TV screens are rectangles measured by the length of their diagonals, and so it's 4 to 3. So the standard is 4 to 3, right? So it's 4 to 3 to 5, and then the horizontal length of a 27 inch. So this must be 27 inches. So the horizontal length is 27 times 4 over 5, which is 28, 108 over 5, which is 21 point, yeah, it's 21.6. So it's D, because it says it's closest to which of the following. So it's D. Number 7, the symbolism x floor denotes the largest integer not exceeding x. For example, the floor of 3 is 3, and the floor of 9 over 2 is 4. Compute the floor over root 1, root 2, root 3, all the way to root 16. Okay, so this should be easy. Root 16 equals 4, right? So the biggest integer that we'll get is 4. And so the largest integer not exceeding x, so we have, let's just write it all out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, right? So 1, and then there's 4, and then there's 9, and then there's 16, right? Okay, so up to 4, it'll all be 1, and then from 4 to 8, it'll be 2, from 9 to 15, it'll be 3, and then at 16, it'll be 4. So this much is 3, this much is 10, this much is 7 times 3 is 21, this is 4, so 13 plus 21 plus 4 equals 13 plus 25, this is 38, so the answer is B. Problem 8, the second and fourth terms of a geometric sequence are 2 and 6, which of the following is a possible first term? Second and fourth terms are 2 and 6, okay, so it's a geometric sequence, right? So it's AD squared, AD cubed, so this is 2 and this is 6. So if we divide, 3 equals D squared, so D is root 3. And so the possible first term, so D is plus or minus root 3, so A could be 2 over root 3 or minus 2 over root 3, which is 2 root 3 over 3 or minus 2 root 3 over 3. So any of these is here. Okay, so we see that this is here, so the answer is B. Problem 9, find the value of x that satisfies the equation 25 to the minus second power, which is 5 to the minus fourth power, equals 5 to the 48 over x minus 26 over x minus 34 over x, right? Because this is 25, so this is 5 over minus 34, 26, 60, 48, 12, 12 over x. So this and this are the same, right? So minus 12 over x equals minus 4, so x equals 3. The answer is B. Problem number 10. Nebraska, the home of the AMC, changed its license plate scheme. Each old license plate consisted of a letter followed by 4 digits. Each new license plate consists of 3 letters followed by 3 digits. Okay, so the old ones had letters and 3 and 4 digits, right? So this is 26 times 10 to the 4th power. And then now it's 3 letters followed by 3 digits. 3 letters followed by 3 digits. So this is 26 to the 3rd power times 10 to the 3rd power. So how many times is the number of possible license plates increased? This is 26 squared over 10. The answer is C. Problem number 11. A line with slope 3 intersects a line with slope 5 at point 10, 15. Okay, so since it's 10, 15, the line with slope 3 will be y equals 3x minus 15. And then slope 5y equals 5x minus 35. So what is the distance between the x-intercepts of these two lines? The x-intercept would be 5, 0. The y-intercept would be 7, 0. So the distance is 2. The answer is A. Problem number 12. Al, Betty, and Claire split $1,000 among them to be invested in different ways. Each begins with a different amount. At the end of 1 year, they have a total of $1,500. Betty and Claire have both doubled their money, whereas Al has managed to lose $100. Okay. So if it's A, B, C, A plus B plus C equals $1,000. But then A plus 2B plus 2C minus $100, since he lost $100, equals $1,500. So A plus 2B plus 2C equals $1,600. So A plus B plus C equals 1,000 is right here. If we subtract it, B plus C equals 600. That means A equals A plus B plus C minus B plus C. So we subtract these two, is $400. So Al's original portion is $400. The answer is C. Let Clover X denote the sum of the digits of the positive integer x. For example, clubs of 8 equals 8 and clubs of 123 equals 1 plus 2 plus 3 equals 6. For how many two-digit values of x is clubs of x equals 3? Okay, so for clubs of this to be equal to 23, let's say this of x has to be either 12, 21, 3, or 30, right? So first of all, the sum of the digits can't be 21 or 30 because it has to be a two-digit value. So 21 is out, also it's 30, and so we only have 12 and 3. For this one, 93 to 39, so 3, 3, 4, 5, 6, 7, 8, 9. This is 7, and then for 3 we have 30, 3, 12, and 21. This is 4. So 7 plus 4 equals 11, right? But 11's not here, right? Why is that? Because 3 is not possible, so this has to be 3. So 7 plus 3 equals 10, so the answer is 9. It's D. Number 14, given that 3 to the 8th power plus 5 to the 2nd power is a to the bth power, where both a and b are positive integers, find the smallest possible value of a plus b. So for a plus b to be the smallest possible value, then a has to be the smallest possible value. So b would have to be 2, a would have to be 3 to the 4th power, multiplied by 5. This is 81 times 5. This is 405. And so b is 2, a is 405, a plus b equals 407. The answer is D. Number 15. There are 100 players in a single tennis tournament. The tournament is single elimination, meaning that a player who loses a match is eliminated. In the first round, the strongest 28 players are given a bye, and the remaining 72 players are paired off to play. After each round, the remaining players play in the next round. The tournament continues until only one player remains unbeaten. Okay, so first there are 28 players assigned, and then we have 72 players, right? So there will be 36 matches, and then the 36 winners and the 28 that were given a bye, they would meet again in 64 people, and so 32 people would go up. And then from the 32 people, there will be 16 matches, and 16 people would go up, and then there will be 8 matches, and then 8 people would go up, and then there will be 4 matches, and the 4 people would go up. There will be 2 matches, and 2 people would go up, and there will be the last match, and then the last person is the champion. So the total number of matches played is 1, 2, 4, 8, 16, 32, and 36, all added together, which is 64. So it's 63 plus 36. Which is 99. So it's divisible by 11. The answer is E. Problem number 16. A restaurant offers 3 desserts and exactly twice as many appetizers as main courses. A dinner consists of an appetizer, main course, and a dessert. What is the least number of main courses that a restaurant should offer so that a customer could have a different dinner each night in the year 2003? So 2003, that's 365 days, and 3 desserts, so there will be 3. So the number of combinations could be 3 times, and then if there are a main courses, the twice as many appetizers, right? So the appetizers should be 2a, and the main course should be a. This is 6a squared. This should be bigger than or equal to 365. A squared would be greater than or equal to 60 point something something. So a is 8, so the answer is E. Problem number 17. An ice cream cone consists of a sphere of vanilla ice cream and a right circular cone that has the same diameter as that sphere. If the ice cream melts, it will exactly fill the cone. Assume that the melted ice cream occupies 75% of the volume as frozen ice cream. What is the ratio of the cone's height to its radius? Let's just draw the problem out here. This would be the radius of both the cone and the sphere. Okay, so the volume of the vanilla ice cream is 4 over 3 pi r cubed, and then volume of melted ice cream, this is 75%, right? So it's 3 over 4 times 4 over 3 pi r cubed, so these cancel. This is pi r cubed, and then this equals the volume of the cone. And then let's say the cone has a height of h. Then this would be 1/3 h r squared. So this is pi r cubed, right? So if r squared is taken away, h equals 3 pi r. So the answer, so h is 3 pi r. Ratio of the cone's height to its radius, h over r equals 3 pi r over r equals 3 pi. The answer is 3 pi. Sorry, I forgot to put the pi in the volume of the cone here. So it's 1/3 pi h r squared because the bottom will be a pi r squared, right? So pi h equals 3 pi r. So h is 3r. So there wouldn't be a pi in it. So r cancels, and so the answer is 3. So it's B. Okay, so problem 18, what is the largest integer that is a divisor of this thing for all positive even integers? And so since n is all positive even integers, then these would all have to be odd integers, so this would be odd. Okay, so that's why you don't see any multiples of 2 in here. Okay, so first of all, since there are 5 numbers here, so there must be at least one multiple of 5 here, right? And then here, since there are more than 3, there also should be at least one multiple of 3, right? But then we can't know anything else because there might be no multiples of 7 here, and obviously not multiples of 2 since it's odd. So these two are the only things that we can be guaranteed. So 5 times 3 equals 15. The answer is D. Problem 19. 3 semicircles of radius 1 are constructed on diameter AB of a semicircle of radius 2. The centers of the small semicircles divide AB into 4 line segments of equal length as shown. What is the area of the shaded region that lies within the large semicircle but outside the smaller semicircles? Okay, so this one we can divide the portions kind of like this. So here you see there will be 2 of these equilateral triangles that each have length 1, and so this would be length 1. 2 times the equilateral triangles, root 3 over 4 times 1 squared. This plus, and then there are 1, 2, 3, 4, 5. 5 of the 5 times the 1/6 squares, 1/6 of the circle, right? 1 over 6 times pi times 1 squared. This is root 3 over 2 plus 5 over 6 pi. So this this is the unshaded region, right? And so the shaded region is the whole semicircle, which is 4 pi over 2. So this is 2 pi. So 2 pi minus this much, right? Root 3 over 2 plus 6 over plus 5 over 6 pi. So this is 11 over 6, no, this 7 over 6 pi minus root 3 over 2. This is the same thing as E, so the answer is E. Problem number 20, in rectangle ABCD, AB is 5 and BC is 3, F and G are in C, these are DF is 1 and GC is 2, AF and BG intersect at E, find the area of AEB. Okay, so this is 5, this means that this part here is 2, and if we put something here, then we can see that DF is 1, GC is 2. Okay, so GC is 2, right? Yeah, so if this is A, then this would be 3A, right? But then and that's because this and this triangle, they are similar. And then if this is 2B, this would be 3B, right? So this would actually be 2A, since this triangle and this triangle are also similar. But then we know that this length is 2, right? Since it's 5 minus 1 minus 2. So we can see that 2 equals 3A, so A equals 2 over 3. And so find the area of AEB. The area of AEB, this is not AED, AEB, this is 1/2 times base, which is 5, times height. And the height is 3A, so 3 times 2 over 3, since A is 2 over 3, plus this much. This is 3. This is 5 over 2 times 5. This is 25 over 2. This is 12. Yeah, this is just 25 over 2. The answer is D. Problem 21. A bag contains 2 red beads and 2 green beads. You reach into the bag and pull out a bead, replacing it with the red bead regardless of the color that you pulled out. What is the probability that all beads in the bag are red after 3 such replacements? Okay, so let's just draw like a stick diagram of everything. So first you have red, red, green, green. You start with that, and then you have an equal chance of taking out a red and then replacing it. So that would be red, red, green, green, or taking out a green and then replacing it with a red. That would be red, 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 green. This would happen at 1 over 2, 1 over 2, and then this would also separate into. This would be the same thing here. So red, 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 green, red, red, green, green. So this is 1/2, 1/2, right? But then we have to multiply it to here. So this is 1 over 4, 1 over 4. And then this one, this could be 4/3 of the time. No, 3/4 of the time it would get a red. So it will be red, 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 green. 4/3 of the time, no, 3/4 of the time, this multiplied by 1/2, so this is 3 over 8, and then it could just, and then it could just become red, 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 if you choose the green. So this is 1 over 8, and then 3 such replacements, right? So you have one time left. This would be R regardless of anything, since it's all red. So this is just 1 over 8, drop straight down. Red, 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 green. You saw what happened here. It's the same thing that will happen here and here. So this would be red, 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 green, or red, 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 red. This will be multiplied by 3 over 4 and 1 over 4. So 3 over 16 and 1 over 16. And then this would be the same thing as above. Red, 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 green, red, red, green, green. We don't care about the probabilities because we only care about the red, 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 reds. And they're not here. This one is also same. this could be red, 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 green, or red, 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 red. This one will occur with a probability of 3 over 3 over 32. And so since we're only looking at the red, 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 reds, we have this, this, and this. So it's 3 over 32 plus 1 over 8 plus 1 over 16 equals 3 over 32 plus 4 over 32 plus 2 over 32. This is 9 over 32. So the answer is C. Problem 22. A clock chimes once at 30 minutes past each hour and chimes on the hour according to the hour. For example, at 1 p.m. there is 1 chime, and at midnight there are 12 chimes. Starting at 11:15 a.m. on February 26, 2003, on what date will the 2003 chime occur? Okay, so 11:15 a.m. Okay, so it will chime once. So on February 26, it will chime once for the 11:30, and then it will chime 12 o'clock. This will be 12. This will be 12, and then from 12:30 to 12 o'clock again, there will be the chimes for the quarter of for the half of the day. So there will be, so let's first find out this much. There will be 1 every 30 minutes, right? So 12:30, 1:30, 2:30, 3:30, 4:30, 5:30, 6:30, 7:30, 8:30, 9:30, 10:30, 11:30. So this is 12. So there's 12 plus, and then we have the 1 at 1, 2 at 2, 3 at 3, 4 at 4, 5 at 5, all the way to 12 at 12. So 1 plus 2 plus 3 plus 4 plus 5, all the way to plus 12. This is 12 times 13 over 2. This is 6 times 13, which is 78. This is 12 plus 78, which is 90. So there is 112 and then 90 more. So the important thing is that 12:30 to 12 o'clock again is 90, and so 1 full day will have 180 chimes, since this cycle repeats twice. And so for February 26, we have 103, right? 103 chimes. And then so for it to have the 2003 chime, we need to have 1,900 more chimes. So this means 10 more days, which has 1,800 plus 1 more day, which will get up to the remaining 100 that we need. So this is 11 days later, and it's 2003, so it's not a leap year. So it's 26 and then 27, 28, 29, no, not 29, 28, and then 1, 2, 3, 4, 5, 6, 7, 8. So this much is 10 days, and then 9. So this will be the date, March 9. So the answer is B. Problem number 23. This regular octagon has an area of 1 square unit. What is the area of the rectangle ABEF? Okay, so let's say that one side has, let's make these lines. This line, and then put a line here, and then put another line here, and then put one more here, and then we're all set to go. Okay, so let's say that this much is A, and this is root 2A, right? And so the area of ABCDEFGH is 1 square unit, right? So 1 equals this much is A squared and A squared, so it's 2A squared plus this is root 2a, this is root 2a, right? So it's also 2a squared plus this much is root 2a squared times 4. So 4 root 2a squared. So a squared equals 1 over 4 plus 4 root 2. And so a squared equals 4 plus 4 root 2 over 1. The area of the rectangle ABEF would be root 2a times 2a plus root 2a. This is a times 2 root 2 plus 2. This is a squared, right? And so since a squared is this is 2 root 2 plus 2 over 4 root 2 plus 4, which is 1 over 2, so the answer is D. So it's D. Number 24. The first 4 terms in the arithmetic sequence are x plus y, x minus y, xy, and x over y in that order. Okay, so it's an arithmetic sequence, right? So xy would be equal to x minus 3y, and x over y would be equal to x minus 5y. And so the fifth term would be, okay, so the fifth term would be x minus 7y, right? And so from here we can know that x equals minus 3y over y minus 1. And here, if we put that in here, x equals xy minus 5y squared. So since xy is x minus 3y, x minus 3y minus 5y squared. Okay, so take out the x's. So 3y equals minus 5y squared. 3 equals minus 5y. Y equals minus 3 over 5. And so if we put that in here, this is minus 3 over 5 minus 1. So this is minus 8 over 5. And then minus 3y would be 9 over 5. Would be minus 9 over 8. And so x minus 7y, this is minus 9 over 8 minus 7 times y, so it's plus 21 over 5. This is, this is 168 minus 45 over 40. So this is 123 over 40. So the answer is E. Last problem, problem 25. How many distinct 4-digit numbers are divisible by 3 and have 23 as their last 2 digits? Okay, so for this one, we need something 23, right? And so for this to be divisible by 3, these two, so if this is A and B, A plus B has to be either 1, 4, 7, 10, 13, or 16, right? But because it can't go to 19, and have 23 as their last two digits. So there will be one possible arrangement, only 1, 0, and then for 4 there will be 1, 3, 2, 2, 3, 1, 4, 0. So this would be 4. And then similarly, the 1-digit number, that will be 7. This will also be 7. And then 10, this would have 9, 1, all the way to 1, 9, all the way to 1, 9, right? So this would have 9 possible values. 13 will have 9, 4, 2, 4, 9. So 4, 5, 6, 7, 8, 9. So there's 6 values. And then 16 would be 9, 7, 8, 8, 7, 9. So this is 3. So 1 plus 4 plus 7 plus 6 plus 9 plus 3 equals, this is 10. So this is 10, this is 10, this is 10, equals 30. So the answer is B. And that was problem number 25, and thank you for watching.